Hello, this is Mr. G, and this is question 12 on the practice periodic that is available on our Physics 1 website that you should be looking at. So here we've got a BMW traveling with constant velocity, 20 meters per second, passes a police car at rest, and then the police car starts to accelerate to catch up to the BMW at a certain rate, and then the question is, how long will it take the police car to reach the BMW? So it's asking about time. So first I'm going to kind of draw a sketch representing the situation here that will help you kind of organize your thoughts about how to solve the problem, because there's not a fixed solution to these problems. These are not problems where you memorize an equation, plug in the numbers, and get an answer. These require a little bit more analysis on your part and reasoning and logic, but you have all the basic information required to do this kind of a problem. So let's say we worked it out in class today, and I'm going to go ahead and redo this now for you to review. All right, so let's see. So first, like I said, draw a little picture, okay? You don't have to be an artist. Right, so here we go. So here's your little beamer. And it is zipping along here at a constant velocity of 20 meters per second. So that means it's not speeding up, it's not slowing down, it is cruising with a constant speed. If you were to look at the speedometer of this guy right here, the needle would be stuck on 20 the whole time you're driving, meters per second, okay? And then you drive right past a police car, right? So, and the police car is initially at rest. That tells you that the initial velocity of the police car is 0 meters per second. Previously, we've been working problems where there's just one object moving, and so you read the question and you write down everything you know in terms of, what is V naught, what is V final, what is the displacement, what's the time, etc., etc., etc. In this case, you have two different objects, so you write down what you know about each of those objects. I'll use a different color here to help me differentiate. Or you could, like for example here with the police car, I could write velocity of the police car initial. That's just too many little numbers though, right? I'm just going to use blue. Remember, it's the police car. So his initial velocity is 0 meters per second. Because he's parked, and he's enjoying his breakfast donut, all right? And then once the BMW passes him, he takes off to catch up with the BMW because the BMW is speeding. He needs to get a citation, right? And so what they tell you about the police car, although it started at rest, it has a constant velocity of 2 meters per second which we can write as 2 meters per second squared. And then the question is, how long will it take the police car to reach the BMW? So what you're looking for here is time. Right, at some point down the road, these guys are going to meet, right? Like I said, initially the BMW is driving, so it's going to pass up the police car. But the police car is increasing its velocity continuously. So it's going to catch up with that little beamer there. So some point down the road, here's your beamer. It's still cruising along at 20 meters per second. And the police car, shoom, has caught up to him. Got his little light on. Okay, and so then the question here is, at this position, what is the time required, okay? Oh, my goodness gracious, this seems very complicated. And it is a complicated problem. It involves two different objects moving differently from each other it's like an algebra problem you might see, right? Because solving this requires a little bit of algebra and a little bit of knowledge of physics. So here's how we're going to do this. Recall that in class today I said, so what do these two motions have in common? You know, for example, what about the delta x for each of these guys? Well, since we started timing over here at this position, and we stop the timing when they catch up to each other, that means that the delta x for both these guys is the same. It is the same for both cars. And not only is their delta x the same, the time for each of these cars in this problem, it's the same time. Okay? That reminds me of the Henkel corollary. In order for two objects to collide, they must be at the same position at the same time. Now, these do not collide, right? The police car is one lane over from the red car. So same distance, same time. So let's just do this now. Let's say, what do we know about describing distance for moving objects? Well, we have an equation that says, so to describe distance for objects that are moving, we have an equation that tells you if it has constant acceleration, then its displacement is equal to initial velocity times time plus 1/2 its acceleration times t squared. So that equation is true for both of these cars, okay? So let's analyze each car separately. And again, the deal is the delta x and the t, they're the same for both cars. They meet at the same position down the road. Okay. So let's just look at each car separately. So for example, for the BMW, its velocity is constant. That is, it's not speeding up or slowing down. It's cruising with constant rate. So then what does that tell you about the acceleration of the BMW? It's not accelerating. It's cruising at a constant rate. That means that, yeah, this equation up here works, but we can pretty much say, yep, its acceleration is 0. So the position of the BMW is given by delta x is equal to v, and we don't have to write v naught or v final. The velocity is constant, so just v times t. And in the case of the BMW, let's see, its velocity is 20 meters per second. So its position is 20t, all right? Then let's look at the police car. Let me do that again. I'm trying to write here again. The motion of the police car is different, okay? But it's still a motion with a constant acceleration. The police car starts off at 0, so it starts off at rest. So its initial velocity is 0. Its acceleration is 2 meters per second squared. So then write the same equation here for the police car. So that's going to give me that delta x is equal to, well, the v naught is 0, so I can leave that part out. So it's just 1/2 times a, which is 2 meters per second squared, times t squared. All right, so that means that for the police car, its position, make some room up here, is 1/2 of 2 is just 1, so it's just t squared. All right, So those are two equations. The one in red describes the police car. The one in blue describes the BMW. But the delta x's are the same. That means, if delta x is t squared, and if delta x is 20t, that means that t squared is equal to 20t. So, yay. And now you just a little bit of algebra here. I can cancel a t on both sides. So guess what? The time it takes for those two guys to catch up to each other is 20 seconds. So, problem done. In the next question after this one, I guess it was number 13, the question is, how far down the road do they meet each other, right? So again, that's asking for our delta x. So for example, consider the BMW. Well, we know that its position, we've already got that. It's equal to 20t. All right. And that 20, by the way, has units of meters per second. Well, if it's 20 seconds, that means the position of the BMW is 20 meters per second times 20 seconds. So 20 times 20 is 400. And then the dimensions, seconds cancel, so we end up with meters. Yeah, so 400 meters down the road. But wait, what about the police car? All right, let's just double check to make sure that's consistent. All right, so the position of the police car in time is given by delta x is equal to t squared, remember? All right, so that's going to be t is 20 seconds. Also, sorry, the units in front of this thing are actually, it's 1 meters per second squared. Sorry, my bad. Okay, so that just turns into 20 squared, all right? 20 seconds squared. And 20 squared is 400. And then the seconds squared here cancels these seconds squared, and you're left with meters. So this is consistent. They meet at the same place 400 meters away down the road. And again, just a reminder, you won't learn this material by watching me do the problem or looking at this video and listening to me do the problem. You need to get a sheet of paper in front of you and then a pencil and a calculator, and you need to do the problem yourself multiple times. So there we go. Have a great evening.